everyone and welcome back to Study Room. Before starting the video, I would like to say, don't let the numbers bother you because mathematics is all about playing with numbers. So in today's video, I'll be teaching you a chapter of mathematics that is mensuration. Sounds interesting? So let's get into the video to know what mensuration is and what are the things that we'll be learning under this chapter. So first things first. What actually mensuration is? Mensuration is a branch of geometry that deals with the measurements of length, area and volume. The first thing that we'll be studying in mensuration is perimeter. So perimeter is the total length of the path of a given shape. So in simple words, I can say that perimeter is the total length of the boundary of a given shape. If I have a circle, then the total length of this boundary of a circle will give me the perimeter of the circle. Now what is area? Area is basically the total region that is covered by the given shape. If I have a circle, so the total region which is present inside the boundary of the given shape is known as the area of a given shape. Now what is volume? Volume is actually the space that is occupied by a given solid. The total space. If I take a rectangular box and it is a cuboid of course. So if I say that the rectangular box is occupying a space of 10 centimeter cube. So 10 centimeter cube is the volume of that rectangular box because it is the space that the box is occupying. So henceforth we can say that volume is actually the space that is occupied by a given shape. Now, we have been given a park of length 30 meters and breadth 20 meters. Let us name this park as A, B, C and D. So, ABCD represents a park whose length is 30 meters and breadth is 20 meters. The first question is to find the total length of the fence surrounding it. So, here just remember, whenever we have to find the total length of the fence, we put the fence along the boundary of the park, along this rectangle. So what we have to find? The total length of the fence is actually equal to the total length of the fence will be equal to the perimeter of the rectangle. And we know that the perimeter of the rectangle is 2 times length plus breadth. So we have to write 2 times. The length of the park is 30 and the breadth is 20. So I'll write 30 plus 20. And the unit of perimeter is same as the unit of each of the sides, that is meters. So it will be meters. Now 30 plus 20 gives us 50. So 2 times of 50. That ultimately gives us 100 meters as the perimeter, or we can say the length of the fence that is required to surround the park. Now the second question is, how much land is occupied by the park? So we have to find the area of land which is there within this rectangular park. So in order to find the area of a rectangle is length multiplied with breadth. The length we have is 30 meters which is multiplied with breadth, that is 20 meters. So ultimately the area which is there within the park is 30 into 20, that gives us 600, and the unit of area is square units. So we'll have meter square. So the area of the park is 600 meters square and the length of the fence required will be 100 meters. Moving on to the next question. The next question that has been given to us is that we have a park ABCD and a path of 1 meter width is constructed all along the inside of this park. Now what we have to calculate is the number of bags of cement that is required to construct the cemented path if the information given to us is that 1 bag of cement is capable of covering an area of 4 meters square. So in short, we have to calculate the area of the path first, and then using the information that 4 meters square area can be covered by 1 bag of cement, we have to calculate the number of bags of cement that is required to construct the path all along the inside of this park, and the width of the path is 1 meter. So let us find the area of the path first. So the area of the path will be the total area of this rectangle ABCD subtracted by the area of this inner rectangle, that is EFGH. So area of ABCD is AB multiplied with BC, and area of EFGH is EF multiplied by FG, because area of rectangle is always length multiplied with breadth. So now we have AB multiplied with BC, that is equal to 30 multiplied by 20. So we have 30 into 20. Now just focus over here. We have EF multiplied with FG. To calculate EF, we have to subtract 1 from this side, 1 meters, and 1 meter from this side in the total length AB, because the width of the path is 1 meter. So if we subtract 1 meter from both the sides to AB, we get EF. So EF is equal to 30 minus 2, which is equal to 28. So I'll write EF is equal to 28. And then we have to calculate FG in the similar manner. So FG is BC subtracted by 2, because again the width of the path is 1 from this side and 1 from this side. So when we subtract 2 from BC, we get FG. So it's 20 minus 2, that gives us 18 meters. So I'll write 18 meters. Now 30 multiplied by 20 gives us 600, and 28 multiplied by 18 gives us 504. So ultimately our answer is 96, and the unit will be meter square. So 96 meters square is the area of the path. Now we have to calculate the number of bags of cement. When 4 meters square area can be covered using 1 bag of cement. So we'll be using unitary method. If 4 meters square can be covered in 1 bag of cement, 1 meter square can be covered in 1 by 4 bag of cement, and thus we can say that 96 meters square area can be covered in 1 by 4 multiplied with 96 bags. Now 4 ones are 4 and 4, 24 is 96. So ultimately the number of bags of cement required is 24 bags. So this is our final answer of the number of bags of cement that is required to construct the cemented path all along the inside of the park. Moving on to the next question. Again we have the same park of length 30 meters and breadth 20 meters. We have a path of 1 meter width all along the inside of the park. Now inside the path there are 2 flower beds, each of length 1.5 meters and breadth 2 meters. Now what we have to do is that we have to calculate the area of the grass that needs to be laid, area on which the grass needs to be laid. Now where the grass needs to be laid? The grass is required to be laid on the inside of the path, leaving the flower beds on the remaining area. So in short we can say that this is the area on which grass needs to be laid. So in order to calculate the area on which grass needs to be laid, we have to calculate the area of this inside rectangle EFGH minus 2 times area of each flower bed, because grass should not be laid on the flower bed. So we'll subtract the area of each flower bed from this area of inside rectangle, that is EFGH. So the area of EFGH will be length multiplied with breadth. So this gives us 28 multiplied with 18. So I'll write 28 multiplied with 18 is the area of EFGH. Now we have to calculate 2 times the area of flower bed, because both the flower beds have the same dimension. So we'll write 2 times. Now the area of flower bed will be the length of the flower bed multiplied by breadth of the flower bed. So I'll write 1.5 multiplied with 2. Now 28 into 18 gives us 504. So we have 504 over here, minus 2, and 1.5 into 2 gives us 3. So ultimately we have 504 minus 6. This gives us 498 meters square, and this is the required area that needs to be covered with grass. Now I'll be teaching you the perimeter and area of some of the geometrical shapes. The first shape that has been given to us is a rectangle. So first we have to calculate the perimeter of a rectangle. The formula for calculating the perimeter of the rectangle is 2 times length plus breadth, or we can say 2 times the sum of the adjacent sides of the rectangle. So over here the length is B and the breadth is A. So I'll write 2 times length is B and breadth is A. So ultimately the perimeter of the rectangle will be 2 times A plus B, where A and B are the adjacent sides of the rectangle. Talking about the area of the rectangle is the product of the length and breadth. So the length over here is B and breadth is A. So ultimately the area of the rectangle will be AB. The next geometrical shape that we have is a square. The perimeter of the square is 4 times its side. The side of the square given over here is A. So the perimeter will be 4A. Talking about the area of the square is side into side. So the side given over here is A. So I'll multiply A with A, which will ultimately give us A square, which is the area of the square. Moving on to some of the more geometrical shapes. Next up we have triangle. Now let us name the sides of the triangle as A, this side as B and this side as C. So the perimeter of a triangle is the sum of the sides. So the sides is A, B and C. We'll add them up to get the perimeter. So the perimeter of a triangle is the sum of all of its sides. So it's A plus B plus C. Talking about the area of the triangle is half into base into height. So the area over here will be half. The base given over here is B, so it's again B. And the height given over here is H, so it will be half BH. Now the next shape we have is a parallelogram. Let us consider the adjacent sides of the parallelogram as A and B. So the perimeter of the parallelogram is just like the rectangle, 2 times the sum of its adjacent sides. So it will be 2 times A plus B. Talking about the area of a parallelogram, the area of the parallelogram is base multiplied with height. So it's base multiplied with height. The base given over here is B and height is H. So the area of this parallelogram will be base multiplied with height. The next shape that we have over here is a circle whose radius given is R centimeters. Okay, the unit is not mentioned, it's simply R. So in general, when we write the perimeter of the circle, remember one thing. The perimeter of the circle is equal to the circumference of the circle. The entire length of this boundary is known as perimeter and that is also known as circumference. So circumference of this circle whose radius is R is given as 2 pi R. So this will be the perimeter of the circle. Moving on to the area, that is the region enclosed within the boundary, it will be pi R square, where R is the radius of the circle and the value of pi is equal to 22 by 7, or sometimes we also write the value of pi as 3.14 for calculating our problems. Now that I have taught you the formula of some of the geometrical shapes for calculating the area and perimeter, let us try solving some problems. The figure that has been given over here is a parallelogram. We have to calculate the perimeter and the area of the parallelogram. So, I hope you all remember that the perimeter of a parallelogram was 2 times the sum of its adjacent sides. So, the adjacent sides given over here is 14 and 7. So, it will be 14 plus 7. Ultimately, this gives us 2 times of 21. So, the perimeter of this given parallelogram will be equal to 42 centimeters. Now we have to calculate the area of this parallelogram. The formula for calculating the area was base into height. The base of this parallelogram is 14 centimeters and the height is 7 centimeters. Now I told you that the area will always take up unit as square unit. So here the unit of area will be centimeter square. Now 14 into 7 gives us 98. So this gives us 98 centimeters square as the area of this parallelogram. The next figure that we have over here is a semicircle. Now to calculate the perimeter of the semicircle, we have to first calculate half the perimeter of the circle. So half the perimeter of the circle will give us pi r. Because the total perimeter of the circle is 2 pi r, so half the perimeter of the circle will be pi r. Now, this gives us the length of this half boundary of the semicircle. but the perimeter will be the total length of the boundary. So we have to add up this diameter as well. This entire circular region is actually pi r in length. And now we have to add up the diameter as well to get the perimeter. So the diameter is 14 centimeters. Now I told you that the value of pi is 22/7. And the radius of the semicircle given is 7 centimeters. So I'll write 7 plus of 14. So the 7 and 7 gets cancelled up. So ultimately we have 22 plus of 14. That gives us 36 centimeters as the total perimeter of this semicircle. In order to calculate the area, now a semicircle is half the area of a circle. Area of a circle is pi r square. So area of the semicircle will be half pi r square, which is equal to half. Instead of pi, we'll be writing 22/7. And the radius given to us is 7. So it's 7 multiplied with 7. This 7 gets cancelled out with this 7. 2 gets cancelled out with 22 and we get 11. Ultimately, we are left with 11 multiplied with 7. That gives us 77. So the total area of the semicircle is 77 centimeters square. The next figure that we have is a triangle. And we have to calculate the perimeter and the area of this triangle. In order to calculate the perimeter, I told you that the perimeter is equal to the length of all the sides. So the length of all the sides given to us is 14. So I'll add 14 with 11 and then again I'll add it with 9 because these are the length of each of the sides of a triangle and the perimeter is A plus B plus C. So I wrote 14 plus 11 plus 9. Ultimately, this gives us 34 centimeters. Talking about the area of this triangle, the formula for calculating the area is half into base into height. So I'll write half into, the base of this triangle is 14 and the height is 7. So base is 14 and the height is 7. So this 2 will get cancelled up with 14. 2 into 7, 14. And then 7 multiplied with 7 gives us 49. The unit of area will be centimeter square. So the area of this triangle is 49 centimeters square. The next figure that we have is a rectangle. And for calculating the perimeter of the rectangle, the formula is 2 times the sum of its adjacent sides, that is 2 times length plus breadth. So I'll write 2 times, the length of this rectangle is 14 and the breadth is 7. So this ultimately gives us 2 multiplied with 21, that is equal to 42 centimeters. In order to calculate the area, the formula is length multiplied with breadth. So the length of this rectangle is 14 and the breadth is 7. So ultimately we get 14 into 7, that is 98 centimeters square as the area of this rectangle. The last figure that we have over here is a square. And the side of the square is 7 centimeters. So for calculating the perimeter of a square, the formula is 4 times the side of the square. That is 7 centimeters. So 4 into 7, this gives us 28 centimeters as the perimeter of the square. To calculate the area, the formula is side multiplied with side. Each of the side is 7. So I'll write 7 into 7. That gives me 49 centimeters square as the area of this given square. Now that I have taught you the area and the perimeter of square, rectangle, circle, parallelogram, I'll be teaching you how to calculate the area of a new figure, that is trapezium. So in a trapezium, we have 2 parallel sides and 2 non-parallel sides. So the trapezium given over here is ABDE. Now in this trapezium, if we join this line EC, like we have to construct this line EC, which is parallel to AB, such that it divides the trapezium into 2 figures. One is this rectangle ABCE and the other is the triangle ECD. So, to calculate the area of the trapezium, we can say that the area of trapezium will be equal to the area of this rectangle ABCE plus the area of this triangle ECD. Now, the area of rectangle ABCE will be equal to length multiplied with breadth. So the length over here is BC multiplied with the breadth is AB. So this is the area of the rectangle. Now in order to find the area of the trapezium, we have to add up the area of the rectangle with the area of triangle. So I'll add up the area of the triangle. The area of the triangle will be half multiplied with base into height. The base over here is EC and the height is CD. So I'll be writing EC multiplied with CD. Now when we combine the area of these two figures, that is a rectangle and a triangle, we get the area of the trapezium. And this general simple formula for the area of the trapezium will be half multiplied with the sum of the parallel sides of the trapezium multiplied with the perpendicular distance between those parallel sides. So over here, if this is a trapezium, the area of this trapezium will be half multiplied with the sum of the parallel sides. The parallel sides are AB and CD. So it's AB plus CD. This is the sum of parallel sides multiplied with the perpendicular distance between the parallel sides. So the perpendicular distance between the parallel side is H over here. So I'll be writing H. So half into AB plus CD into H is the area of the trapezium. So we have to remember this basic formula of area of trapezium, which is equal to half into sum of parallel sides multiplied with the perpendicular distance between the parallel sides. Now that I have taught you the formula for the area of trapezium, let us discuss this problem. So Nama's sister has a trapezium shaped plot and it is divided into three parts. So this WXYZ is a trapezium shaped plot and it has been divided into three parts. That is, this is a triangle, again we have a rectangle and then a triangle again. So we have to prove that the area of this entire trapezium is half A plus B into H. That means it is satisfying the formula that is equal to half into the sum of parallel sides, that is A and B, multiplied by the perpendicular distance between them H. So we will try proving it. So I told you that the area of trapezium will be equal to the area of the sum of all the figures it is divided into. So here the trapezium is divided into three shapes, that is two triangles and one rectangle. So when we add up the area of this triangle, this rectangle and again this triangle, we'll be getting the area of a trapezium. So first of all, the area of the trapezium will be equal to the area of this triangle, that is half multiplied with the base of this small triangle is C and the height is H. So the triangle is half C into H. Now in order to get the trapezium, we have to add the rectangle. The rectangle area is length into breadth. The length of this rectangle is B and breadth is H. So it will be B into H. Now we have to calculate the area of this triangle. In order to calculate the area of the triangle, the formula is half into base into height. So here we'll write half. The base of this triangle is D and the height is H. Now from all these three terms, let us take half and H common. So if I take half and H common from all the three terms, we'll be left with C plus 2 times of B plus D. Now this can further be written as half H C plus B plus D plus B, which ultimately gives us half into H. Now just observe over here, C plus B plus D is equal to A, as it is mentioned in the figure, that C plus D plus B gives us A. So I'll write A and then we are again left with a B. So I'll write A plus B. I think we met the proof requirement. That is, the area of this given trapezium WXYZ will be equal to half H A plus B. I hope it's clear now. Now, in the previous question, we have been provided with a trapezium that was divided into three separate parts, two triangle and one rectangle. Now, let us try calculating the area of each of the separate parts and let's add them up to calculate the area of the trapezium. So, the first part that was given to us was a triangle and the area of the triangle will be half into base into height. So the first triangle that was given to us had this area half into C into H. So this will be half. We'll be putting the value of C and H from the given question, that is 6 centimeters and 10 centimeters. So the value of C is 6 and H is 10. So ultimately this gives us 30 centimeters square as the area of the first triangle. Now the area of the rectangle which was there inside the trapezium was B into H. So here this area of the rectangle will put the value B equals 12 and H equals 10. This ultimately gives us 120 centimeters square. The area of the third triangle within the trapezium was half into D into H. If you're not able to recall, just go back to the previous slide and see the dimensions in the figure. So this will give us half. The value of D in the question is 4 centimeters. So we'll be putting 4 centimeters multiplied by H, that is 10. So this gives us 2 into 10, that is 20 centimeter square. So ultimately what we'll do is add the three areas to get the area of the trapezium. So the final area of the trapezium that we have will be equal to 120 plus the area of the two triangles that we calculated, that is 30 plus 20, which sums up to 170 centimeters square. So this is the area of the trapezium when we calculated it in separate ways. Now we know the direct formula of the area of trapezium, that was half the sum of parallel sides, that was A plus B into H. Why not put the four values of these given things in the equation and calculate the area of the trapezium directly and check whether this area is equal to the previous area that we calculated? So over here what we'll do is we'll write half. In place of A, we can also write C plus B plus D. Refer it from the previous figure. And again we have a B over here. Instead of A, I wrote this thing. That is C plus B plus D. Now this will be added up again to B. And we have H, because the formula is half into sum of parallel sides into the perpendicular distance between them. So this gives us half into the value of C in the question is 6. The value of B is 12. Again the value of D is 4. And the value of B is 12. Multiplied with H is 10 centimeters over here. So here we have half. Adding up 6 plus 12 plus 4 plus 12 gives us 34. So this is 34 into 10. 2 times 17 gives us 34. So ultimately the area of the trapezium we get will be 170 centimeter square. Now what do we observe? That this area is equal to this area. So ultimately if we calculate the area of the trapezium in separate ways and if we calculate the area of the trapezium by directly putting the values into the formula, the area will be the same. So it is verified that the area of the trapezium is half into the sum of its parallel sides into the perpendicular distance between them. Now that I've taught you the formula of calculating the area of trapezium, let us calculate the area of the following trapeziums. So the first figure we have is this, where the length of the parallel side is 9 centimeters and 7 centimeters and the perpendicular distance between them is 3. So for calculating the area, the formula is half into the sum of the parallel sides. So it will be 9 and 7 because 9 is this parallel side and 7 is the length of the other parallel side. Multiplied by the vertical distance between them, that is 3 centimeters. So ultimately we have half multiplied with 16 multiplied with 3. 2, 8 times 16. So ultimately the area of this prism trapezium will be 8 multiplied with 3, that gives us 24 centimeters square. Don't forget to write the unit. This is a common mistake that each and every one of us do. Now in order to calculate the area of this trapezium, here the length of the parallel sides are 5 centimeters, 10 centimeters and the perpendicular distance between the parallel side is 6 centimeters. So in order to calculate the area, the formula is half multiplied with the sum of the parallel side, that will be equal to 10 plus 5 multiplied with the perpendicular distance between them, which is 6. So ultimately we have half multiplied with 15 multiplied with 6. 2 3 times gives us 6 and 15 multiplied with 3 ultimately gives us 45 centimeters square as the area of the given trapezium. Now that I have taught you the area of trapezium, we will move on to a general quadrilateral. That is a four-sided closed figure. In order to calculate the area of this quadrilateral ABCD that has been shown in the figure, what we have to do is we have to join this diagonal AC, and after doing that, it divides this entire quadrilateral into two triangles. The first triangle is ABC and the second triangle is ADC. So we can say that the area of this entire quadrilateral ABCD can be written as area of triangle ABC added up with the area of the other triangle, that is ADC. Now, let us try showing you something. That is, the first thing we have is area of triangle ABC. Area of triangle, everyone knows the formula, that is half multiplied with the base of this triangle, which is AC. So I'll be writing AC. And the height of this triangle is H1. So half AC into H1. Now, in order to calculate the area of this entire quadrilateral, I have to add up the area of ABC triangle with the area of triangle ABC. Now we have to write the area of triangle ADC, which will be equal to half multiplied with base into height. Again, the base is AC and the height over here is H2. From these two terms, we will be taking half and AC common. So we'll be left with H1 plus H2. So from here we can conclude that in order to find the area of a quadrilateral, either we can separately find the area of these two triangles, or the other interesting thing we can do is that we can use this formula, that is half AC H1 plus H2. Let me explain how will you remember it. You can do so like you have to take half multiplied with the common base. This is the common base to both the triangles multiplied with the sum of the heights from the opposite vertices to this common base. H1 is actually the length of this perpendicular from the opposite vertex B to this base AC. Again, H2 is the length of the perpendicular from this opposite vertex D to this common base BC. So ultimately the area of the quadrilateral can be written as half into common base multiplied with the sum of the heights from the opposite vertices to the common base. So I hope it's clear. Let's try solving a problem based on this in order to clear our concept. Over here we have this quadrilateral PQRS, and QS has been joined such that this quadrilateral is divided into two triangles. So the area of this quadrilateral will be equal to the area of these two triangles. That means adding up the area of both the triangles. So I taught you an easier method to calculate the area of the quadrilateral, and that is a direct method. And the formula that I taught you was half multiplied with the length of the common base of both the triangles. The common base is QS and the length of this common base is 5.5. So I'll be writing 5.5. Now this has to be multiplied with the sum of the heights from opposite vertices to the common base. So here H1, that is this height, is 2.5, and H2, that is the height of the other triangle, is 1.5. So I'll be writing 1.5. Ultimately, it gives us half multiplied by 5.5 multiplied with 2.5 plus 1.5 gives us 4. Now this 2 will be getting cancelled up with 4, leaving behind 2. 5.5 multiplied with 2 gives us 11. So ultimately, the area of this quadrilateral will be 11 centimeter square. We all know that a quadrilateral is a four-sided closed figure. So a parallelogram is also a quadrilateral. Now we know another fact about parallelogram, that when we join any of the diagonals of a parallelogram, it results in the formation of two triangles of equal area. So over here, if we have a parallelogram ABCD and we join this diagonal BD, it will result in the formation of these two triangles of equal area. Now, let us see that if we add up the area of these two triangles separately, do we get the area of parallelogram or not? So, the area of this triangle ABD area of the triangle ABD, will be equal to half into base into height. The base of this triangle is AB, which is equal to B, and the height is H. So I'll be writing half into base into height. Now again, we have another triangle, that is triangle BCD. Let us calculate its area. So area of triangle BCD will be equal to, again we have half. The base of this triangle is CD, which is equal to B. So it will be B, and the height of this triangle is also H. So again we get the area of this triangle is half into base into height. Now let us sum the area of these two triangles. Adding the area of these two triangles, that is area of triangle ABD plus area of triangle BCD, we get half BH plus half BH. So ultimately, we get the area of the entire parallelogram, that is equal to BH. Now, I have already taught you the area of the parallelogram. That was base into height. So if we directly calculate the area of this parallelogram ABCD, that will be equal to the base of this parallelogram, which is equal to B, and the height of this parallelogram, which is equal to H. So ultimately we get the area of the parallelogram as BH. Now observe one thing, that this area of parallelogram that we directly calculated is equal to the sum of the area of these two triangles. So this is the first observation, that the diagonal of a parallelogram splits up the area of the triangle, the area of the parallelogram into two equal triangles. And the second inference is that the area of these individual triangles will also be equal. So the diagonal of a parallelogram splits up the area of the parallelogram into two triangles of equal area. So these are the two observations we draw when we find out the area of the parallelogram.